Okay, section 5.2, probability distribution. That's the chapter 5, and today we're going to, talk binomial probability, talk about the binomial probability distribution. So it's a probability distribution where you have two choices. Binomial means two choices. Okay, and also eventually the goal is interpreting the final result and find out which one is significantly low value or significantly high value. So first of all, if you have given a probability distribution, we need to find out either that is binomial or not by testing these four criteria. So a binomial distribution supposed to have fixed number of trials. If the trial is more than fixed, then that's not binomial. The trial must be independent whenever you do one trial first time, and if you go to the next trial, the outcome of the next trial is supposed to be independent to the previous trial. Think about flipping a coin and getting a head or tail. That's the No matter how many times you do, the trial the outcomes are independent. And each trial must have all outcome classified exactly into two categories. So that's the reason it's called binomial. You're supposed to be able to divide your outcome as a two category. For example, when you flip a coin, we can divide that outcome as a head and tail, two category. The probability of a success remains the same in all trials. It's always same. So these are the four criteria we have to supposed to test to find out either our probability distribution is binomial or not. So these are the notation we're going to use. Let's assume that S stands for the success and F stands for the failure of any outcome we are looking for. So the probability of success, let's say that's a small p, and then probability of failure is complement of the success, so that's a small q. Let's assume that small n represents the total fixed number of trials. So for the binomial probability distribution, we use a variable x, a specific number of success in n trials. So x can be any whole number between 0 and n. So for example, we flip a coin 5 times, and we would like to find out what is the probability of finding 2 heads out of 5 trials. In this case, head for us is success, so x is equal to 2 heads out of 5 flipping, so x is 2. So you cannot have more than your head, the outcome head could be up to 5, in between 0 to 5. So that's the meaning of 0 to n. P stands for the probability of success. In this case, getting ahead is a success. So Q stands for the probability of failure, which is getting a tail or not head. And P of X represents the probability of getting exactly X success among the n trials. So in our example, exactly 2 heads in 5 trials. Keep in mind, success doesn't mean the same thing for different trials or different results. For example, in our example here, getting a head is success, but next time in next experiment or next example, it might be getting a tail or something else. So it's up to you and your situation. How do you define the success? It could be different thing for different trials. Okay. So one more thing you have to keep in mind: the x, the random variable, which is number of success, and p, which is the probability of success, they represents the very same thing. We also use the 5%. We also use 5% guidelines rule here in this section as well. If your sample size is less than 5%, then we treat the selection, even it's without replacement, we treat that selection as independent. And this is the formula we can use to calculate binomial probability distribution. So what is the probability of finding exactly two head out of 5 trials? In this case, in this example, n is 5, p is, what's the probability of getting head, which is 0.5. What is the probability of complement of head, which is again 5. I'm just giving you one example. And x is, we would like to find out two heads, so these are the value we're going to plug here. Keep in mind, in this section we use technology like StatCrunch. So we can, yes, we can calculate this this information using manually using some calculator, but StatCrunch would be more efficient. Okay, we can find mean, variance and standard deviation using these formulas after finding n and p. So these are the formula we can use. And as we saw in previous section 5.1, any value less than mu minus 2 times the standard deviation, they are assumed to be significantly low values. Any value greater than mu plus 2 times the standard deviation, they are assumed to be significantly high values, and any values between these two values are that not significant. Okay, so this is also the very same thing from section 5.1. X success among n trial is significantly high if the probability of getting X or more is less than 5%. Similarly, X success out of n trials is assumed to be significantly low if the probability of getting X or fewer is less or equal to 5%. Here 5% is not it might be 1% or it might be 4%. It's up to the situation, but this is just a one specific number we use most of the time, 5% rule. Okay, so one more time, this is the formula we use to calculate the binomial probability distribution to get exactly X number of success. Okay, exactly X number of success. This first part that calculates exactly X success among n trials, the number of arrangement, which gives you X success among the n trials. This is from section 4.4 counting, and this part calculates the probability. Let's look at some examples from section 5.2. Before we do examples, I would like to just quickly check which of the following is not a requirement of binomial probability distribution. So whenever we try to do problems for binomial probability distribution, these are the 4 criteria we should verify, and choose the correct answer below. The trial must be dependent. No, that's not true, because the trial must be independent, so that's not the requirement. In the binomial probability formula, the variable X represents number of success. Find the for the binomial distribution, which formula finds the standard deviation? If you go back here and then check the formula, the standard deviation is square root of n times p times q. This one is standard deviation. Similarly, we can find the mean by finding n times p. So this is the right formula. And we can find, assume that each of n trials is dependent and that p is probability of success n given trials. So n is the number of trials, and we want to find out what is the probability of getting exactly 3 success out of 15 trials, where the probability of success p is 1/5. We can calculate this using binomial probability formula. The formula I'm talking about is this one. You can do it manually or you can use the StatCrunch. I'm going to show you how to use the StatCrunch, and we're going to use the very same thing. Open the StatCrunch page. If you don't know how to do that, you can just go to statcrunch.com, and then let me see. No, not this. You supposed to be okay. Get more help. When you click one of the problem from get more help, tech help, you supposed to be able to, no, not this problem. Let's go to problem 16. When you go click get more help, in one of the question here, you will be able to see one of the option as a stat crunch, and you can just click that, and then it will be able to give you this page, stat crunch page. And when you do that, where's that? No, the problem was question number 21. Okay, go back to the question number 21. After opening the StatCrunch, click Stat Calculator. Go to Binomial. That will help you for finding the binomial probability distribution. In this calculator, this is the actually the histogram. You have to choose the value of n. In this case, it's a 15. You have to put the value of probability. In this case, it's a half. It's already given. We would like to find out what is the probability of success when x is exactly 3. So px, instead of less or equal, you have to choose exactly 3. So when you fill this information, this is going to be your probability of success when x is exactly 3, which is 0.013. 3 decimal places around 0.014. So 0.014. Great. So that's how we can calculate probability, binomial probability, using the StatCrunch. Oh, so these are the different value. You can check it. But now let's do a couple of more problems. A Gallup poll of 1,236 adults showed that 12% of the respondents believe that it is bad luck to walk under a ladder. Consider the probability that among 30 randomly selected people from the 1,236 who were polled, there are at least 2 who have that belief. Given that the subject survey were selected without replacement, the events are not independent. So events are not independent. Can the probability be found by using the binomial probability formula? So first of all, the subject were asked, do you believe? The answer was yes or no. So it's a two options, two outcome. And then as you can see here, it's a finite number of trials because they were asked to finite number of people. So when you try to check this 4 criteria, the process has a fixed number of trials. The trial must be independent. This is not independent, but we can assume this independent if the sample size is less than 5%. That's the 5% rule. Okay, the sample size is less than 5%. That's the 5% rule. And as you can see here, the probability of success is same. Either you ask first person, your answer is either yes or no. It's a 50%. So this is the binomial probability distribution with the less than 5% samples. So we can treat this as a independent. So we can use the binomial probability formula. So the answer is yes. Although those selections are not independent, they can be treated as being independent by applying the 5% guidelines rule. Okay, let me go jump to the next question. Question number 5 from here. Assume that when human resource managers are randomly selected, 53% say job applicants should follow up within 2 weeks. If 9 human resource managers are randomly selected, find the probability that exactly 6 of them say job applicants should follow up within 2 weeks. Remember, this is a binomial probability distribution and we're supposed to use this formula to calculate this. In this problem, 53% means it's the probability of success P, small value of P, which is 0.53. And then because probability P is 0.53, the Q is 1 minus 0.53, which is 0.47. The value of N is 9, and then value of X is 6. So we can use this formula manually, or we can go to the StatCrunch and fill out this form. The value of N is 9. The probability of success is 53%, so it's a 0.53. And then we would like to find out what is the probability when X is exactly 6. So that's the probability. If you round it to the 4 decimal place, the answer would be 0.1933. 1933. So finding binomial probability is very easy using StatCrunch. So I'm going to try next problem. Assume that when human resource manager are, that's question number 5 we did, right? So let's do something else. Question number 9. Human resource, all the human resource. Okay, so this is different type of question, though it looks like a same one. Assume that when human resource managers are randomly selected, 44% say job applicants should follow up within 2 weeks. That was also the case in question number 5, but this is a little bit different. If 15 human resource managers are randomly selected, find the probability that fewer than 3. This is not exactly 3 this time. This is fewer than 3. That means the value of x is, you need to calculate the very same thing, but you have to calculate when x is 0, x is 1, x is 2. So that's fewer than 3. Fewer than 3 means either it's 0, 1 or 2. So you need to use the very same formula 3 times and you have to add these values. But using the StatCrunch, finding this value is very easy. Go to the StatCrunch one more time and plug this value. It's a number of human resource 15. Out of 15, the probability of success is 44%, so 0.44. This time x is less than 3. So instead of 0, 1 and 2 calculating for individual cases, we can use the StatCrunch and we can just hit compute. That will calculate everything. Okay, look at here. If you calculate for 0, this is the answer. For 1, this is the answer. For 2, this is the answer. You can add all 3 cases and that becomes less than 3. That gives you less than 3. So this is the answer for this question. So that is 0.012. So that means if you round to the 4 decimal place, this 9 becomes 10. So it's a 0.013. 0.013. That 9 becomes 10. Good job. I'm going to do one more question here. A pharmaceutical company receives large shipments of aspirin tablets. The acceptance sampling plan is to randomly select and test 56 tablets, then accept the whole batch if there is only one or none that does not meet the required specification. So what they are doing is, for each shipment, they just select randomly 56 tablets, and out of 56 tablets, if 0 or at most 1 tablets does not satisfy the situation, then they would reject that box. They would reject the shipment. So now the question is, if one shipment of 6,000 aspirin tablets actually has a 4% rate of defect, so this is the probability of defect. This is 0.04. Now what is the probability that this whole shipment will be accepted? Remember, to accept any shipment, there's supposed to be 0 failure or 1 failure at most. So the probability of success of this shipment depends on the probability of failure. So if there will be 0 failure plus 1 failure, these are the 2 cases where we accept the shipment. So this can be calculated. It looks very complicated problem, but if you go to the StatCrunch and if you fill out these boxes, so number of tablets 56. What's the probability of failure rate of the tablet? 4%. How many failure we want? At most 1 failure we want. At most 1 failure. That's why this P is probability of success for this experiment. So this is the chances of successing that no tablets, at most 0 or 1 tablets are is failure from that 56 tablet. This is the probability of success, which is 0.3388. So if you round it to the 4 decimal place, it would be 0.3389. Remember, I use this probability of failure as a probability of success because finding 0 failure or 1 failure is actually our success. So we can use this as a probability, this 4% as a probability of success. The company will accept. If you want to convert that into percentage, it would be 33.89 percentage of the shipment, and reject. If they accept 33.89, they reject 100 minus this, which is what is that? 66.11, because if you add these two numbers, that will be 100. So the company will accept 33.89% of the shipment and will reject 66% of the shipment. So many of the shipments will be rejected. Many of the shipments will be rejected. So that can be found using the StatCrunch and the binomial probability distribution formula. Okay, that's section 5.2.